Hello everyone. This video is about common emitter amplifier. Common emitter amplifier is basically a BJT based amplifier with its emitter ground. So now the simplest example is this one. Yeah, we have a VCC here and then RC. The output is to be captured from the collector of the transistor. And like what I said here, the emitter is ground, and the input is to be fed to the base. In this case, we have the base here, and most likely you will have an input source here. And do not forget that the small signal is small signal. The magnitude is too small, so you need to bias it. The biasing voltage will be like this here, and it is V0. So altogether, we have two independent DC voltage sources. And there are some procedures to follow in order to resolve these circuits. The number one thing that you need is to replace the transistor with the small signal model. So step one, replace the BJT with this small signal equivalent. The second point that we need is to sort all the independent DC voltage sources to ground. Sort all the independent DC voltages to ground. And the step three, yes, just like what you did in Lofton-Tefton conversions. You just need to open circuit all the independent DC current source. DC voltage sources. I should say that. DC voltage just to ground. And this one, open circuit, all the independent current sources. And step four, just resolve the circuit. Resolve the circuit. Now, with this simple example, the first step is to replace the transistor with the small signal model. One of the small signal model we have learned is the pi model. And it's like this. And then GM, and then the pi. And do not forget to add the early voltage, the early resistance here. And this is R pi and E, B, and C. too high. Yeah, I have to withdraw it. You know, and then our pi and B, C, E. And now the E terminal is connected to the ground. The, the output the output is in the C terminal, which is right, and the output is connected to another resistor, RC. Uh, and RC is in turn connected to VCC. And we know that from step 2, we need to connect short circuit all the independent DC voltage sources. And this is one of those. So we short circuited, and this is another one we short circuited to the ground. So this is the procedure we need to follow. And now we have a resistor here, and this is connected to the ground, RC. And in the input, we have already connected this to the ground, and then what we have left here for the input to the base is the in. So we in. And now we are ready to resolve the circuit. And the V pi is the voltage here. And the current here, IB, small signal current. And this is IC. And I will also define another IC here. And this is IC dash. And this IC dash is the net current coming out directly from the source here, the dependent source here, Gm times V pi. So what I normally do is to start from here. We know that IC dash, which is the net collector current, excluding the effect of the early effect. And this one is going to be Gm V pi. And do not forget that V pi here is actually equal to V in. So we write down another fact here, but V in is equal to V pi. And IC naught. What is IC naught? And based on what we have seen here, IC naught is equal to V out and minus and R naught in parallel with RC. We need to make sure it is a small signal. We need to highlight it. And this one is a small signal. Now with this in mind, we can substitute IC dash with this expression. So this is number 1. We substitute to equation 1. And what we get here is this one. And then R pi, R log in parallel with RC. And now, on the right side of the equation, we have Gm left. And do not forget, V pi here, as we explained earlier, is equal to V in. So V in. So by direct observation from equation 2, we can quickly know the out over V in, which is the voltage gain, is equal to minus Gm and then times out. And there's nothing difficult in this case. And normally we call this term, this ratio as voltage gain. And how about the input resistance? The input resistance by direct observation is R pi. The output resistance is RC. And how about the current gain? The current gain in this case is output. First of all, in order to find the current gain, we need to know the output current here. By direct observation, IR is equal to minus IC. And the input current, I in, is equal to IB. It is also equals to V in divided by R pi. So if you want to know the current gain, we can easily resolve the equation. We still have a little bit of space here. I out divided by I in, which is the current gain, is equals to IC and V in. Yeah, by the way, what is IC? We previously has already found out IC. Yeah, I'm not talking about IC dash. IC is we know V out divided by RC minus. Okay, so now this one and then divided by this one, right? The input, right? So V in times R pi. And then we need to substitute IC here. Yeah, I'm not talking about IC dash. So what we can do is we use the we now divided by RC. Now, do not forget the minus sign here. And then R pi, and then V in. So now we are almost done. And I'm going to erase this little space here and continue. So first, I copy this line here. Yeah, I naught I in, it is equals to minus IC, and then R pi, and then V in, and then I'm going to substitute IC based on the information here. V naught divided by RC, and then take the minus. We will get the value of IC. So R pi, and then V in. Now it's pretty clear now. Once you are in this step, then we know that the current gain is actually the voltage gain, and then the voltage gain, and then the R pi and RC, and the voltage gain is given here, Gm no, RC, and then times R pi RC. So this is done. For the current case, this is the expression that we expect to get. Now, the problem is, in the real life, the common emitter amplifier is not going to be that simple. One of the reasons is, uh, this common emitter amplifier has a lot of drawbacks. One of the drawbacks is it requires two batteries. One is VCC, another one is V naught here. And for such a simple circuit, we don't really need two resistors. So ideally, we use the stem source of voltage, VCC here, to bias the base as well. So this will also optimize the circuit economically. On the other hand, the small signal is difficult to apply at this point here. What we can do is modify this circuit to a more realistic version. Now let's start with another example, and this is going to be example 2. And we are not going to use the original circuit. This circuit is almost okay. Yeah, I mean, without the base, it is almost okay. It is a common emitter amplifier. But however, the base here is not effective, so we need another version. And what we can do is we bias it using the same method. We use the same VCC here. And then we bias the base separately. R2. So this is basically the bias level. And now how the input and output can be applied to the circuits. It's very easy, and what we need is just a coupling capacitor. And this coupling capacitor can filter off all the DC voltage. So now, if you apply the input voltage here, then the small signal input voltage will, at the end, add on to the original voltage here. Suppose you have a V B here as a result of the bias, then the voltage at this point will be V in plus VB. And I'm not going to make it dirty. And by the same token, if you directly tap the output from the collector in terminals, you will also attract the DC voltage as well. So what you need is just to use another capacitor. And this one C1, C2, and the coupling capacitor C1 and C2 can filter off all the DC voltage. On the other hand, it's also much more convenient than before. And the circuits here require only one batteries. Now, we can follow the same steps, same procedures to solve this problem. First thing that we need is to replace the transistor with the pi model or any other small signal model. So we do that first, assuming that we don't know the circuit. So this is the pi model. The pi model is like that. And now the next step is to connect the VCC to ground. And for this circuit, we have only one independent DC voltage. So now this one is connected to the ground. And with this in mind, we have a resistor, we have this point here, which is the collector. Collector, yeah, this one. And the collector is a point where we tap the output in high frequency AC signal. Capacitor is conducting, just like a short wire with very low impedance. So we just approximate the circuit. We now, this is what we do. And the collector is also connected to RC. And this RC is another terminal shorted to the AC ground. Remember, it is not the physical ground. And in small signal analysis, all the independent DC voltages are shorted to ground. So this one is no exception. It is ground. And in AC frequency, in high frequency, this ground makes no difference with this one, even in microwave or any other high frequency circuit. And you have a fixed voltage, we assume automatically they are ground. Whether they're, even though there may not be any metallic connection between this point and this point, it's okay. As long as the voltage here is fixed, it is ground. So this one is grounded, and this one is connected to a resistor, and which in turn connected to ground. And now, how about here? This end is connected to the ground, R1 and R2. So basically, R1 and R2 is a parallel level. R1 and R2. And the input at AC in high frequency, this C1 is conducting like a normal wire. And then we can just say the in is pi at this point. So this equivalent circuit is equivalent to this one here. And our analysis will be based on this equivalent circuits. And to start with, like what I did before, I usually start from this point here. IC dash is equal to GM times V pi, and this is equation 1. And what is IC dash? And the thing is, right, IC dash, according to here, is the voltage divided by the combined resistance here. So IC dash is equivalent to V naught divided by R naught and then ROC. So we can substitute from equation 1 to further elaborate there. Yeah, I'm going to add a little bit more space here. This is very difficult to make. I see naught, and this one is GM. Now, the next thing that we are going to do is to work out V pi. And fortunately, V pi here is exactly the same as V in. So V pi is equal to V in. So this is a very good news. And what we can do is to substitute all these things to equation 1, like what we did in example 1. So IC which is this one, V naught divided by RC, yeah, do not forget the minus. And GM is here, and V pi according to this definition here, it is equals to V in. Okay, so this is equation 2. So like what we did before, and you automatically found the voltage gain. So there is no difference at all. The voltage gain remains the voltage gain. The only difference that we have is the input resistance. Previously, in example 1, the input resistance is R pi, but for this one, obviously, if you look at the resistance here, it is not R1. It is the parallel combination of R1 in parallel with R2 and in parallel with R pi. So RE is equals to R1, R2, R pi. So this is tricky, yeah. Now, the next thing that you would be interested in is the current gain. I'm going to show you how to find the current gain here. And we don't have enough space. Maybe we can write a few more lines here. And I out. Let's define I out here. Okay, I out is according to here is V minus IC, and which is minus which is V out divided by RC. Okay, and the next step is to find V in. I in, yeah, I in. We can see I in is the voltage, V in divided by the term of the resistance, divided by R in. So V in divided by R in, and V in will remain. And R in we have already established. According to this equation, it is R1, R2, and R pi. I'm going to check if you can read the right one. Well, just enough. Okay, now the next thing is to find the current gain based on what we have got here. What we have got current gain is normally we symbolize the letter G, okay? And this is R divided by I in. And according to here, I out, the output current is V out divided by RC. And according to here, V I in is equal to that much. And the trunk of expression, R1 in parallel with R2 in parallel with what R pi. Okay, so we are going to erase this circuit, right? And then we continue. And this one is equal to V out divided by V in, and then this guy here. And it's going to be downhill now. V out divided by V in can be found from here. And then out of And then so it is that simple. If you have any questions, please leave your questions to the comments box. And if you have time, we will try to resolve your questions. Thank you very much. Bye-bye.